Okay, and hello, I am Shasman Harith, and this is the presentation for the Data Science 360 January 2022 cohort of the Capstone project. So for this project, I'll be presenting on the Langkawi mean sea level. So the purpose of this is to predict the Langkawi mean level over years. So where I got this data from is from the sea level info. So sea level info actually compiles the data of the Langkawi mean sea level from the 1980s to 2018. So it is quite an interesting website. So I obtained this data, which is in a JSON format. So from here, I wanted to see does the Arctic or Antarctic sea level also has an effect on the mean sea level of Langkawi. So those I got from the National Snow and Ice Data Center Sea Ice Index website. So is really interesting. It has the data. It has monthly or daily data. So from here, I actually got the daily data. So what I'm going to do now, so compiling the data from the sea level info and the sea index, I want to create a new CSV file. So I go into my Google Colab. So this is where I work on cleaning the data so that it can be processed inside the BigQuery, which I will do the prediction. And also with this new file, I can also present the sea level and also the Arctic level better. So this is my work on the Google Colab. So the first step is to import the Langkawi mean sea level into the notebook, and then going down, I also imported the Arctic and Antarctic CMS data into this Google Colab. So of course, there are some strange anomalies going on. You can see on this graph here. So apparently, the order of the year is not in proper order. So I had to rearrange it. So now it looks better. So just a little bit of overview. This is created on Seaborn. So the blue line indicates the mean sea level, and whereas the red line is actually the rolling average of the sea mass, the ice mass of, you can see here the north extent, so the Arctic sea mass. So you can see it's a neat line, but this is actually a rolling average. So all the way down here is to import or export the dataset of CSV. So you can see here, this is the new Langkawi mean sea level that has both the Arctic and Antarctic ice mass as well. So all this data is actually I've already placed it in my Kaggle. You can visit Harishas. I can visit both of the datasets. One is the mean sea level and also daily sea ice index. So I placed this dataset into my Kaggle. You can visit there. And okay, so the first thing that I did was to go to BigQuery, and of course to do the prediction, I did the ARIMA model using the BigQuery. So this is the code, and then finally in here this is for the forecasting. So okay, so that is the background of my working. So now as for the findings, as we can see here on this is the visualization of the mean sea level of Langkawi, and you can see here throughout the year from 1987 to 2018. Like why 2018? Because that is the only method or the time where this, you can go back here, called the permanent Service for Mean Sea Level conducted the study in Langkawi. It was only up to 2018, so I believe that is a great opportunity for me to actually predict what could be the mean sea level moving forward. So this is actually why I also took this data sets. So you can see here the mean sea level has always been around 7 meters each year, and that hasn't really changed much except for to in you can see here in 1997 it's gone down to 6 meters and gone back to 7. So overall, Langkawi, the mean sea level of Langkawi has not really changed that much. It's always been stable 7. We go further down is the Arctic ice mass. So it was a daily data set, so I actually made an average for that to show instead of monthly, daily. So I changed it to yearly instead, so yearly average. And you can see here on the blue line, it always goes up and down, up and down, up and down. So it's quite hard to read from here. So that's why I have to do the moving average instead. Moving average, there's not, and you can see here it's always been in the region of uh, 11 million square 11 million square meters. So this is very large. So that is the average. And so this is for the Antarctica. Antarctica also the same. So it's always around 11 million square meters. So moving on to the mean sea level. So putting the moving average over the mean sea level Langkawi, we can see here that there isn't really much changes. Like even there, although there are drastic changes on the Arctic uh, ice mass, the sea level of Langkawi doesn't seem to change that much. It seems to be it's always on the 7. It is also the case for Antarctica. So yes, there are like maybe a increase. Actually, interestingly, there's actually an increase in ice mass in Antarctica actually. So all the way to 12 million square meters. Yet our sea level doesn't seem to have any effect. That's it. So of course, this is just a basic exercise of showing the trying to find a correlation between Antarctic ice mass to the increase in sea level Langkawi. But sea level, there are many factors that could affect the increase or the decrease, such as the moon phase, sea temperature. There's many factors. But just for this exercise, it's just to show there's correlation between the Arctic and Antarctic ice mass and sea level, or maybe there's no correlation. So if we look at the correlation analysis over here, it is not a very conclusive study. However, it is just an interesting to see that there there isn't really a strong correlation between the Arctic, but there is somewhat uh, a little correlation with the Antarctica ice mass. As you can see here, for Arctic, for example, it is 0.01 compared to Antarctica is 0.3. So, as I mentioned earlier, there are many factors that could affect the sea level. So this is just a simple exercise just for this project. So moving on to the forecast. So this is created from the ARIMA model which I made from BigQuery. So the orange line represents the trend, and over the years starting from 2018, there will be the increasing trend. Whereas the pink line is the upper bounds, and the light blue is the lower bound. So the blue line is actually what will be the prediction of the mean sea level. So as you can see here, the line goes up and down. So mean sea level of course, when I first did this, I was thinking that maybe it's going to show a straight line, but then maybe I realized maybe the pattern is such because the sea level is always dynamic. It always goes up and down, up and down. So I believe this could be something that what it will look like uh, for something like a sea level. So you can see here, like over the years, it will always be increasing all the way up to 2049. But even in the prediction, it increases. It will not go further above 7.29 meters. So this is my conclusion from this exercise that based on the ARIMA model generated from BigQuery, the mean sea level is forecasted to increase steadily over the years. However, sea level is dynamic and cyclical with many factors affecting the sea level. Factors such as moon phase, sea temperature, and also land erosion could contribute to the rising sea level, and not only in Langkawi, but also other places. And also, this is an exercise. I end this message that we have to protect our environment, and of course, protect our sea. And we only have one Earth, so we have to look after it. Thank you very much. And so, this is the end of my presentation. Thank you.